Welcome to Masters Bloomingdale Academy. So in this video we are going to discuss about some of the important topics regarding modern periodic table. So in the previous videos we discussed about Mendeleev's periodic table and what were the salient features of the table, as well as we discussed about limitations. So in this video we are basically discussing about modern periodic table. So what is modern periodic table and what was the need for this periodic table? As you know that when Mendeleev arranged the elements, or when he classified the elements according to the physical and chemical properties, he divided the elements in vertical columns known as groups and as well as horizontal rows known as periods. So when he arranged the elements, he was getting some limitations. That means he was not able to explain some points or topics relating to like anomalous series, why the elements were arranged in anomalous series, and there were some other limitations. So to overcome these limitations, H.J. Moseley, he proposed this modern periodic table based on the modern periodic law. Is it clear? So now let us see what is this modern periodic law. So according to this law, the periodic functions of the elements, they are depending upon the atomic number. So by chance or by accident, which H.J. Moseley identified this atomic number during his research on X-rays, he found out that the atomic number is very important while classifying the elements. So what he has done, he arranged the elements according to the atomic number. So when he arranged, so these limitations were overcome. So this is one of the best classification of elements which is based on modern periodic law. And in the previous classes we discussed about the orbitals. Basically you are having four orbitals: s orbital, p orbital, d orbital and f orbital. So you can see that in the periodic table we are having four blocks. So these four blocks are s block, p block, d block and f block. So this side you are having s block of the periodic table, and on this side you are having the p block, and in the middle you are having d block, and the bottom you are having the f block. So this is the classification of the periodic table. So now we may have some doubt regarding these elements. So why these some elements are placed in S block? These elements can be placed in P block. At the same time, the P block elements can be placed in D block. But here you have to remember that the last electron or the differentiating electron or the valence electron, you have to see the valence electron or the differentiating electron where this electron is entering. If it is entering the s orbital, then we are placing that particular element in s block. If the last or the differentiating electron is entering the p orbital, then we are placing that particular element in p block. If the differentiating electron is entering the d orbital, then we are placing that particular element in D block. Similarly, F block. So now let us see the example of sodium. The atomic number of sodium is 11. So What is electronic configuration or the arrangement of electrons? You have 1s2, 2s2, 2p6 and 3s1. Now you can see the important thing is that 3s1. So the differentiating electron is entering into s orbital in case of sodium. So that's why the sodium is placed in s block elements. So similarly, when you see aluminium, the atomic number of aluminium is 30. So now let us see the electronic configuration. 1s2, 2s2, 2p6, 3s2 and 3p1. So p1. So the differentiating electron is entering into the p block. So that's why we are placing this aluminium in p block elements. So I hope that you are able to understand this topic. So like this, the elements are placed in S, P, D and F block. Is it clear? Now we will discuss about groups and period. What is a group and what is a period? So in the periodic table you may have seen vertical columns. Vertical columns, they are known as groups. And the horizontal rows, they are known as periods. Is it clear? So now how many columns are there? So when you count all these columns, you will have 18 columns. That is, we can say that there are 18 groups in the periodic table. So similarly, when you see the horizontal rows, you are having 7 rows. So you can say that you are having 7 periods. My next question is that how these elements are placed in different groups and different periods. Is there any property? Is there any thumb rule how they are placed? Now we will see the thumb rule how these elements are placed in different groups and periods. So now let us see the association of the elements with periods. So these periods are represented by Arabic numerals 1 to 7. So now let us see why hydrogen and helium, they are placed in first period. The reason is that the first period always starts with first main shell. So what is the first main shell? K is the first main shell. So remember that K main shell, it has one subshell. What is that one subshell? It is 1s. So remember K main shell, so it has one subshell. So one subshell, what is that one subshell? It is 1s. So S, it can take 2 electrons. Is it clear? So that's why we are placing hydrogen and helium in the first period. So similarly, when we are taking the second period, we are adding one more main shell. Already K is there in that particular second period. So the second period is starting. So you have to take the second main shell. So here the second main shell is L. So L, it has 2 subshells. What are these 2 subshells? These 2 subshells are 2s and 2p. So we know that 2s, it can accommodate 2 electrons. Similarly, p, it can accommodate 6 electrons. That means we can take 8 elements in the second period. So similarly, when you are taking the third period, so third period, it contains one K main shell, L main shell, and one we are adding new main shell, that is M main shell. So like this, we are taking the shells. As the periods are increasing, we are adding one more shell. So like this, the elements are categorized. So this is the thumb rule which you have to remember. Welcome to this new session So in this session we are going to discuss about metals and non-metals. In your 8th class you have studied about the properties of metals. So there you studied that metals are lustrous, they are malleable and they are ductile. So what is the meaning of lustrous? That is, they are very shiny, they are bright. So they are having a lot of brightness, these metals. So similarly, malleability. So these metals can be made into sheets. So similarly, they are ductile. That means these metals, they can be made into wires like copper wire, aluminum wire. So these are some of the properties of metals. But how to actually classify metals and non-metals? So basic thing is that you have to see that the electrons present in the outer shell, you have to take the outer shell. If the electrons are 3 or less than 3, then we are saying that they are metals. So similarly, if you want to say that non-metals, so you have to go to the outer shell. If you are having 5 electrons in the outer shell or more than 5 electrons, then we consider it as a non-metal. So this is the rule for identifying a metal and a non-metal, even though there are some exceptions. So now let us see what are these D block elements. They are basically known as transition elements. So what are these transition elements? They come from 3rd group to 12th group. So here the metallic property is decreasing from left to right. When you go from left to right in a period, so the metallic property is gradually decreasing. So now in these transition elements we are also having inner transition. What are these inner transition elements? So you have heard about lanthanides and actinides. So these lanthanides and actinides, they come under the inner transition elements and they belong to the 3rd group. When you see the 3rd group, some elements are missing here. The numbers are missing. So these elements are found in the F block, but they are taken as inner transition elements. So this thing you have to remember. So when you go to the right side of the periodic table, we can see that there are metalloids or semi-metals. That means they have the properties of both the metals and non-metals. You can see a staircase in the periodic table. So this staircase is a demarcation. On the other side, so you will be having metalloids. What are the metalloids? For example, you are having silicon, germanium. So these are some of the examples of metalloids which are present near to the staircase. Is it clear? So this is about metals, non-metals and metalloids.